Yes. Try now.
Can you hear me now?
Check the chat.
Yeah.
Yes. Now, yes.
Can you hear me?
Yes.
If the Zoom people can hear.
Yes, if other people can hear me now?
Yes, we can hear you, Christophe.
Yes, yes. Okay, okay, we're good. All right, let's get back to the presentation. No. Sorry, it's full screen. That should be it. Okay, so back to the agenda. So as I said, introduction, challenges, the technical approach, then we'll do a live demo of the package. Then we'll open up for what we think would be good to do next and discussion about all this. Okay.
Are you sharing
so
something, Christophe?
Let's start with an introduction. So that's the 5G super blueprint. I'm sure some people at least have seen that. So as you can see, it's quite a bit of a set of open source that are listed there. So some of you are usually familiar with one or two, but this is really the view of a 5G end-to-end stack.
You're not sharing the presentation on the Zoom.
Let me share. Hopefully they should see it now. Okay, so last interruption, hopefully. Okay, that's the 5G super blueprint. As you can see, many open source. Most of us are familiar with a couple of them, but what we are looking to do here is to try and get to a point where we could test all of that, deploy all of that first together and test all of that. So we took the challenge, okay? So to try and build something that's easy. Now, as I said, many open source means that, well, they all have kind of different technologies, even if most of us are delivering containers these days. They obviously are constantly evolving, which is good, but at a different pace. So you need, if you are going to deploy them, you need to find a way to really manage dependencies and make sure that you have a way to level set everything to deploy your end-to-end stack. Another challenge is that we found that during our exploration that environments are not all the same. Either people don't have the same resources or labs are limited. And when you see that amount of open source, if you want to deploy everything, that might be a challenge. And we've heard many voices say, well, we don't need everything. We may need a couple of open source to do a particular use case or want to demonstrate a bit of it, but there needs to be a way to, choose easily what you want to deploy. So the challenge is really that, to create an environment with a consistent way to manage that. So we started building a solution and we wanted to do something that's really self-contained. So that means that you don't want to have to do things in a different way, and you want it to be really easy to understand. And so the guiding principle was really to reuse what's best from the different open source, combine them to obtain the best setup, and the customization should really be minimal and at the top. We just want to pick them from their release repositories, deploy them, and just customize for what we need. And the goal of all that is to try and use these open source like a reference stack. Because, you know, when we speak about 5G, there are a lot of standards, and we want to use the open source to be a reference test bed. And so that's one of the key drivers for all of this. Now, some of the highlights I'd like to point out is that, yeah, we want this to be easily extended as well, because we know people will have different use cases. They want to maybe use their own tools. So we want something that is kind of open on what you can add or remove. And you see the last one also, as I said, we want to provide multiple flavors. That's one of the key things about this, is that we want people to choose. If they want a small setup, they can do. If they want a huge setup, they can do it as well.
And also I can add, the 5G for blueprints is really a driver. I hope really to establish what we have done as the first step toward any 5G for blueprint test bed that the community can use to validate 5G stack from different vendors or different communities.
Okay, so what did we do? So this started quite a while ago, so approximately, I would say, yeah, 1 year from now. So we've been through several steps. We'll walk you through these steps so you get a feel of how we built this solution. So the first thing, as I said, we were looking for a place to start, really, and we picked up the SMO because maybe for those who have seen the presentation before, SMO is defined by the ORAN Alliance, and it's kind of reusing a lot of ONAP components, which we were very familiar with, and adding on top the connectivity really to the edge with the DU and radio units to materialize really the 5G edge. And so we started discussing with the ORAN SC community, which built some of the components that ONAP didn't have. So this is what you see here, the non-real-time rig. And we started looking at different flavors. As I said, we wanted something small that we can try out, so just really for a POC, and then grow up on that to increase the scope. And we built a medium flavor, and you can imagine even a larger flavor where we would mostly deploy all of ONAP and other open source to materialize that view. So the first focus was on the small flavor and try to exercise the standard API. So in the ORAN Alliance, they define the O1 and A1 API, which are really what we are going to try and test once we have deployed the components. So we started discussing with the ORAN SC community. So how would we deploy all of this? So we were kind of familiar of the way ONAP was deploying using the OOM charts, which are umbrella charts on top of all the component charts. So Helm charts that deploy on a Kubernetes cluster. And we kind of thought of multiple ways to do that. So either we rebuild OOM-like charts for ORAN, or we reuse the capacity of ONAP to orchestrate. And we could think of building a CNF package. So an Helm package that you would onboard onto ONAP that would deploy and grow and be controlled by ONAP itself. So ONAP would orchestrate and deploy the needed components. Now that was more complicated, of course, so we didn't start with that. And we started thinking about the use case we wanted to do, okay? And of course, that's where we started also thinking, well, if we combine ONAP and ORAN together, we might as well combine other component, and this is where we thought, okay, this might be a first step to the 5G Super Blueprint deployment. So how did we see that? So in an ideal world, because we are not yet there, we would have some deployment instructions. That's what you see in the middle of the screen, that would go and fetch the charts. The charts are picturing how you get the containers and deploy them from the different charts repo. Now, in reality, we don't have that yet, because even though we publish containers in Docker or in Docker Hub or in the Nexus repositories, the charts themselves, they have to be built locally. So we've done some scripting to be able to pull the charts and build them locally, put that all in the same repo, and then deploy to the target cluster. But that's one of the key points what we'll be discussing today, is maybe this is something one day when all components deploy their charts to a public repo, that would be much more easier. And we would, as I said earlier, we would just pull the charts as is and essentially create overrides file with the configuration we want. And that's the ideal again. We don't have to tweak the deployment. It should be flexible enough so that we can really deploy it the way we want. So the first thing we did, as I said, was to do the proof of concept. And so instead of pulling these charts individually, we reused the Git submodule features to load up the OOM charts, and we created makefiles the way the OOM did for the ORAN components, and these charts are built locally and pushed to a common repo. And we can use these to test the override, the first version of the override file. So I'm not going to do the demo of that today, but you can find the demo in a recording that we did during a presentation to the ORAN ONAP SMO joint call. So I put the link there, you will find it in the presentation. Okay, so now we have found a way to deploy the whole thing. What can we do next? Well, we created another override to test our idea about CNF. So we bundled some of the simulators that the ORAN SC had to simulate the radio unit and the topology server. So we bundled that as a CNF package. We extended the SMO to include SDC, ANAI, SO for the orchestration, and we onboarded that CNF package to ONAP and deployed it with ONAP. The idea here is that you could use the orchestration capabilities of ONAP to control the simulator, so to grow your simulated environment, to shrink it, or to do configuration change even through CDS. Now, disclaimer, there is a demo of that as well. I'm not going to demonstrate that today, but there is a demo of that as well. You will find the link there. And a little disclaimer is that this was the second demo, and since then we've done changes, but we haven't retested that. So it might be broken, but at least you'll see it working at some point, okay? Now, the lesson learned from that is that it was working, but it's a bit complicated. So we thought, okay, let's keep on just doing it the simple way. And for the next, so just before I go to the next one, this is the approach. So we built M charts for the RU, DU, and topology servers on the bottom right. We onboarded that as a CNF package to ONAP, which orchestrated this it can be another cluster or the same cluster, to spin up the ORAN simulators. Okay, so next, what did we want to do? Well, first, we were at a point where we believed that this could already be very useful. So we started to build some documentations about how to use that, and you'll get the links later. We revamped a little bit the overrides file to be more, more concise and put them on the right way. And we wanted to build some test automation. So, okay, we can exercise the APIs, but how can we make this reproducible, make sure that it works at any point in time and all that kind of good things. And so we started to build demo scenario to test the O1, A1, and closed loop with the various flavor. Now, this was all very scripty, okay? So you had to go to Linux shell and have a look at all these test results, which can be, you know, very cumbersome sometimes. So we added a tool. So we added Jenkins, which also has an Helm chart to the setup, so that we could onboard all the test scenarios and automate a little bit. Really, we use Jenkins as our UI and our Metacron. Okay, so we built pipelines in there that are automatically deployed, and that can, you will see that later, you can start the SMO, you can stop it, you can run the test, you can choose which from which commit you start the test from. And since we were there, we thought, well, might be interesting to hook it to the Gerrit repositories of DLF, so that whenever there is a change to, I don't know, to the ORAN containers, we could run the test and report status. Okay, so you'll see that later as well. And since this is the last thing we did, we aligned with ONAP Jakarta, so that we deployed the latest version of ONAP and ORAN SMO. Okay, so what does it look like? So we tried to make this as simple as possible. So you have a first layer of scripting, which we call layer 0, which you can use if you start from scratch. So you spin up a VM with Ubuntu, and you want to deploy. So you just install the OS. So the scripts are going to set up all the needed tools, and it's going to spin up a small Kubernetes cluster for you. So you just run these scripts and you're all set with the basis that you need. Then we have the layer 1. I forgot to mention, but the first thing you need to do is obviously pull the repository where this package is. So you just go to Gerrit and you pull the code from our latest version, and then you have all these scripts ready for you. Then you go to layer 1, and layer 1 is going to build the charts. So it's going to do, as I said, build the Helm chart, because we cannot pull them. So it will build them locally and push that to a local Helm repository, so that they are ready for deployment. And then you have a script, well, you have different scripts to deploy the SMO. So it's going to create the ONAP namespace and deploy the ONAP components that you chose, depending on the override flavor. So if you pick a small flavor, you'll have a small amount of ONAP components. But if you pick a bigger one, you will have more components. It's going to deploy the ORAN components, so the non-real-time rig. And then it's going to be able to deploy what we call the network namespace. So this is really where the simulators are deployed. So the simulators that simulates the RU, DU, and topology. And then you have a test namespace. That's where Jenkins and all other toolings are deployed. Then we've reused and extended the ONAP Python SDK to build up the tests. So for those who don't know, in ONAP, you have a test framework written in Python, which allows you to trigger the APIs of ONAP and to combine them, because it's built in such a way that it's reusable, combine them to create test scenarios. And so we've created one for ORAN. So we've extended the ONAP one with ORAN functions. And then we created use cases that can be run and that report test results. And while we were there, we pushed all these results in Jenkins. So you can see the test results displayed into the Jenkins tooling, which is, it has all the necessary tools to do that. So where are we today? So we think we've built something that's able to deploy what I've pictured in red there. So not everything is real because we have simulators to simulate the RU, DU, but we are deploying the ORAN SC software. We're deploying ONAP. We have helpers to deploy Kubernetes cluster. In ONAP, we have the SDN controller, and we can run on different type of hardware because we just need an Ubuntu Linux to run on it. And actually, we've deployed that at several locations. So even in our corporate environment, and we had a nice headaches with proxies, but we were able to make it run. So as I said, where can you find it? So we've worked with a couple of universities where they have deployed user equipment, 5G user equipment. And so our goal was to try and deploy that so we could trial and verify the compliance of these equipment with the standards. So we've deployed that in Cosmos, Powder. And Marshall, you can maybe give us more details there.
Yes, so just one precision for the UNH lab, it stands for the University of New Hampshire. So this is where also the ONAP server are located. So we have side to side the ONAP one and the one dedicated for test.
Okay. So I'll go to the demo now. So before I do the demo, I know this has been seen a little bit before during the SMO presentation, but so that you know, we are going to spin we are not going to spin it because it's already started, because it takes about 40 minutes to spin things up. So we don't have time to do that, but it's already started on the UNH lab. So the SMO is running, and we are going to trigger the test. So the tests are going to spin up a new namespace in the cluster with the simulators. They are going to send events to, so first, I don't know if you're familiar with the flow, but what's happening is the simulators are going to send events through the VES collector, and they will register through SDNR, so it will auto-discover the components. So that's, you'll see the SDNC UI there. And then we are going to exercise the APIs by triggering faults. So the simulator are going to send faults to the netconf client, which are going to be translated to through the VES provider into VES events through the VES collector. So they will be published on DMAP, and the policy in ONAP will see them, and it could, you know, for closed loop, it can act upon it. Okay. Okay, so I'm going to switch screen. So first, I'll do the scripty things. So sorry for your eyes if you cannot read that much, but this is so that's the UNH server, and you can see I've directory there where I downloaded all the repository for the SMO install. And if you look, you have, as I said, we've divided the scripting into layer 0, layer 1, layer 2, and subscripts are scripts that are being used by layer 0, layer 1, and layer 2. You have also uninstalled scripts that you can run. So all the layer 0, layer 1 scripts, I'm not going to show you because they've already been run actually to deploy everything. So if I go to the layer 2, okay, I'm there. You see that we have scripts that are there to help you do everything, and they are very simple. Okay, so install CI/CD is the first script you should run now because it's installing the Jenkins instance that we will go to next. But if you want to do it the old way, you can still, deploy the things manually. You can install the simulators, you can upgrade them, you can install the non-real-time rig, and you can install ORAN, which will install, actually this should maybe be called install SMO, because this installs ORAN stuff and ONAP stuff. So very basic scripts. I'm not going to show you the script, but you can have a look at them. And at the end, what you get is a couple of namespace. So the first namespace you'll get is the test namespace where Jenkins is running. And then you see that I've deployed the SMO because I have the ONAP namespace and the non-real-time rig namespace. If I look at the pod in the ONAP namespace, you can see that ONAP is happily running, and it's a shortened version of ONAP with only SDNC, policy, DMAP, AAF, and the platform basic stuff, okay, for what we need to do today. So next, as I said, we've added Jenkins. So when you look at Jenkins, that's the other UI, what you will get when you spin it up is this dashboard with a couple of pipelines that are pre-configured for you. You see that I've already run a couple of them. So the start SMO pipeline. So first they are divided in two. They are divided in Gerrit and GitHub. This is a kind of historical because we've been working on a GitHub project before committing our stuff to the Gerrit instance, but they are both functional. So if I look at the Gerrit trigger, you see that it's hooked up to the master branch, and it's looking at the reviews, the incoming reviews. You see there is one which is successful here. And if I look at the Gerrit project for ORAN, you see this is this review, which has been, which is open. And the tool has downloaded the code, tested it, and very much like we do in OOM, it has reported status on the review. You see that it's picked up the review, that it's starting the validation, and a while later it will report here. It will report the test results. Okay, so if you take this and you deploy it anywhere, and you put the right credentials on your lab, you'll be able to report status on the test you run on the Gerrit of the LF. Okay. So now that you know what this is, I'll show you the individual pipelines. So as I said, you have a start SMO and a stop SMO. Well, like their name suggests, it's only going to start SMO for you. So you have a visualization of the scripting. So the pipeline is really just for that, to have a manual way of starting the SMO on your lab and stopping it. And then we have a test pipeline, which is going to execute the test. And you see here why we did this is because we get a history pretty much out of the box of how good the test evolved. You see that originally we had 50 tests, and then we added more, so now we have 57. And they were failing at the beginning, and now we can see the last few runs were all successful. Okay, so, and you can look obviously at all the details, what it's doing. So it's setting up the tools, building the charts, and then running the test, then publishing the result. And you get the logs of the test. So this is reformatted to unit test format so that it can be visualized by Jenkins, so that you can get that kind of report. So a test result by which is bundled by the type of test. So we have unit tests, which are really unit testing the test code itself. And then we have the actual end-to-end test, which are the ORAN test. And if I look at them, you see that we have different type of tests. I was saying we test the O1 interface, we also test policy, and we test the A1 simulators. So I'm now going to execute the test. So I'm going to launch that pipeline. I need to log in to do that. So I'm going to build it, and you see it's asking me, okay, what flavor do you want to run? So I'm going to run the basic flavor. Watch branch or commit ID. So if you want to run the test from a different version of the actual SMO you have installed, you can do that. Okay, you just pick up the right point in history of the repository that you have locally to do it. So I'm going to run it. So as you see, the tests, they take approximately 10 minutes to run. Okay, so we'll wait a little bit. And while we do that, I've opened the SDNC UI, so you can see things happening there. So if we quickly, so what will happen is events will start to come into SDNC through the different APIs, and SDNC is going to automatically do an inventory of the simulators that are spin up, and it's going to show the faults that we are triggering. So if I look at the notifications, we should see some coming through once the tests have started, because right now it's still building, it's still setting up the tool.
So maybe to precise that, like Chris said, you can indeed select which branch you want to run when you execute your test, but when you are building up locally the different repo at the very beginning, you need, of course, to have pull all those branches from the remote repository. So that's a key point, because if you don't do that, you won't have them available for you to choose later on. Yes,
Hopefully they can see it. Yeah. Okay, so I hope I didn't lose my connection to the lab.
no.
Get it. No, it's back. Okay. So that's the good thing with the lab being remote. It's not bothered by connection problems. So it's still running and it's starting the tests. So let me maybe relog to the ODL UI. Doesn't like to be disconnected.
Maybe it's the network.
Yeah, I don't know. Jenkins is good. You can still see the progress here, I guess. Yeah. So yeah. Still waiting. Anyway, we can follow the progress directly in Jenkins because it's more verbose, but you get the test being executed. So you see it's first starting to run the unit test on the test themselves, and it starts to execute the different test scenarios, and you get a report here. And if you really want to investigate more, you get the really verbose debug log, where you can see everything that is happening. So for example, here, the first set of tests that we do is we create a policy to verify that it's able to receive events, and you get all the messages that are sent and retrieved either from the map or the different components that are deployed. So it's very verbose, and you can see everything that is happening. Yeah, it's a shame I cannot show the. Try to go back to the ODL again. Responding. No, not displaying me. Maybe I found a bug in the ODL UI. I don't know. Try another UI address. It's responding with error, so I don't know why. Log me in. No. Anyway, you can see the test result. We can see the progress in Jenkins. So it's still running the test. Can try with another instance, yeah. Yeah. I don't know if anybody else is connected on it. So, yeah. Yeah.
But then you can at least see the progress.
Yeah, we can see the progress here and the tests that are still being run. You see, so it's creating and the tests are passed, so it's still progressing.
Maybe you can explain the test.
Yeah, maybe we can, well, the test we've already kind of explained a little bit what it is. So maybe I can show you, we have other tests pending. That's why I was showing you the new Gerrit review that is open, where we've added actually a closed loop test. So we can go and see it because it's from the Gerrit pull request that is open. If I look here, the test result, you see that we have one more end-to-end test case about closed loop that you can find in the debug logs. See, that's the class which is going to test the closed loop. And the first thing we once, yeah.
And this is really with the new clamp. Yeah, that exactly. So
Yeah.
it has been done with the new LCM rebuilt from DM team, and we're reusing the latest clamp closed loop rework.
I saw the URL culture there.
Yeah.
Just upon the sequencer.
Yeah, and so then we go and instantiate a closed loop and check that it's ready to receive events. We still have a little problem about really executing the closed loop, but that's in the works. Set tells me 3205.
Yes.
There we go. There it is. So if I go to the faults,
Sorry, I
you
can
see
speak.
some faults have been received from the simulator, and we get the notifications growing. So it's still testing. So it's sending new events, and they come into the system, and that's how it's discovering. You see, we've named the RU and DU. That's coming from the simulator and the topology, so you can decide how many RU you have per DU. And then we are exercising the API by sending events. And the goal is obviously, once the closed loop is deployed, it will get these and take action. And one of the closed loop action would be to lock a particular RU, which is sending the alarms. That's going to be in a nutshell the test, you see. And we can have a look at the inventory that SDNC has gathered from the PNF registration. So it found out our topology server. We have two DUs. You see 1121 and 1122. And then we have one RU that is hooked to this DU. So it's called 11211. And then we have three RU hooked to the second DU. So 1122, 1, 2, and 3. And it discovered them automatically. Okay, so then we can go back. Hopefully the tests are done. It's completing the build. So if I look at this one, still progressing. So we are close to the end. Once it's going to be done, then the test results will come back. They will be visible here, and it will update the charts with the results. Okay, so I'll stop the demo now. I think we've done most of it. Let's go back to the slides because we have a few more.
Okay.
Yeah, it's coming on the projector. Okay. So what's next? Well, that's what we are thinking to do. So we want to enrich this package with more tooling, discussing with the ORAN SC community. When you start to exercise this, you want to have a tool that's capable of really looking at the packet. So they ask if we could include Wireshark, for example, to really get to see what's being exchanged between the simulator and hopefully one day the real equipment and the system. Also Keycloak, because the simulators, they have integrated that, and so we were asked to try that and maybe also be compatible with service mesh and that kind of things. Marshall is working on adding slicing use case.
Yes, right. In the context actually of the server integration, server being a POC. Use case automation, and we are trying to activate it as we speak, and I'm working closely with the network slicing use case people in order to see what are the new for ORAN SMO. We really limit ourselves on a very small subset of ONAP component. So we are adding more of them, and also adding more simulators coming from the slicing use case, and hopefully we'll reach that. And as part of that effort, we have also deployed the ORAN package on the University of South California, where they're also trying in order to test their saver integration. And also this is all tying up to the 5G spot blueprint, because to test even more use case, to have really a reference test bed for that.
Okay, so that's what we had for today. So ideas. Hopefully you've seen that this is trying to gather everything together and make it real for the big use case that we can think of end to end. So we wish that was interesting to you.
Thank you for the nice presentation. Can you go back to the slide where where we are, where you kind of outlined the
Yeah, this one.
Can you share about your plans or vision for the next steps? Like the other parts of this diagram, do you have in mind to include?
So right now we don't plan to, on the next release, I would say, extend that view, because we have so much use case that we already can do now. Okay, but obviously, I mean, we have the ability to add, and there are things that are not on that slide because we have some toolings that come from other areas like Jenkins that we added, Wireshark. But yeah, we could envision maybe to include Anuket to deploy on different type of labs automatically. A 5G core would be nice, but we've tried discussing with the Magma team and they were not really ready for 5G yet. That's what we understood. Yeah, and obviously you have all the things that you can add at the edge that would be very interesting to try and put some use case. Because I think once we have the closed loop materialized and running, we can really, hook things up and do good stuff. So
yeah, so it's interesting that those were the 2 components I had in mind. Okay, it's very easy. We have people here.
Yeah.
Have a chat with them. And regarding Magma, it's true that there are some challenges with 5G features, but there's work going on in the community. Extend the Magma code base to include the necessary functionality. So I suggest you stay tuned and keep an eye on it, because you might find soon that it's ready for 5G. So it would be a good next step for you guys.
Yeah.
Great work. So.
Thank you.
But of course, I mean, the community is welcome to contribute to it. It's not only our own. I mean, if the Anuket team wants to add up to what is existing, they are welcome to come to us, and we'll help them to contribute to the package and make it even more global.
I had one question on your next slide. You mentioned the roadmap, the network slicing. How you plan to integrate with the current SO workflows with
Yes, that's the plan.
That's the plan.
Yeah, actually, we want to automate the use case that is it has been put in place in TONAP.
Okay, great, thank you.
Not really a question, just a comment. It's really impressive demo, and I think that shows the value of these events. I knew you guys were working on something around this area, but it's only when you see the scope that you realize how much moving parts and how complex it is. And even using the Jenkins to reduce the complexity and implementation, I think was a really cool idea. So,
Thank you. And actually, to your point, when Catherine came to see me and show me this and told me essentially make it work, we found the task would be daunting. But in the end, I think one thing I can say, we've acquired some experience, with all of you guys in the open source, and we have the some habits of taking things together and gluing them so that they work. So in the end, it was challenging, yes, but not so complicated. You'll see when you look at the scripts, they are not that complicated. Okay, maybe on the Zoom, any questions? The chat, maybe.
Luis asked a question from Zoom.
Okay. Question from the bridge.
No one answered.
Okay, so then we'll leave it at that. Thank you.
Yes.